This is the study cast for Chapter 5's math test using multiplication. First one, Carly has 49 stickers. She wants to put 7 stickers on each card. How many cards can she make? So we have an equation here with an unknown factor. What is representing the unknown factor in this equation? Brianna? Right. And we know that this square can be represented as a letter, as a question mark, as a triangle, any other shape, but we know that it represents the unknown factor. So what we need to do is think to ourselves, what factor goes there to make the sentence true? Jojo? 7 is correct. How'd you figure it out?
I counted 7, 14, 41, 42, 45, and I had 7 fingers up.
Awesome. So Jojo skip counted, putting up a finger each time he skip counted. And he wound up with skip counting by 7s 7 times. Next question. Stephanie and John made a table about spiders. Which of the following describes a pattern in this table? Now, this was a multiple choice question, but I did not include the choices. So let's not waste time copying down the table because that takes up a lot of time. See if you can find a pattern that is true for each section of the table. So you're looking for some way to get from the top row to the bottom row. And then that way should be the same for each section. Sometimes these kinds of tables ask us to look from here to here, and here to here, and here to here. Depending on the choices that you're given, there are 2 ways to answer this. So give me one way, Isabella. What's one possible pattern for this table? Okay, 8s is not a pattern though. Give me an operation. Add 8, subtract 8, multiply by 8, divide by 8. Go ahead, Isabella. Okay, so if you're looking from the top row to the bottom row, it's multiply by 8. Multiply spiders times 8. What's another way to describe this pattern? Now let's look this way. Kyle? No. Gianna? Okay, counting by 8s, but you're not starting at 8. So sometimes it's a little bit tricky and we miss the fact that it's counting by 8s because it starts with 16. We didn't start with 8. That's okay, we can start in the middle. I can count by 10s if I start at 50, right? I'm just counting on 50, 60, 70, 80, 90, 100. Just because I'm not starting with 10 doesn't mean I'm not skip counting by 10. So what's another, so we can say skip count legs by 8, or who can use an operation word to describe what we're doing along the bottom there? So is it add, subtract, multiply, or divide by 8? Christina?
Multiply by 8?
No, because if I do 16 times 8, it's not going to give me 24. Kyle?
Divide.
Nope. If I divide 16 by 8, the answer is not 24. Annabelle? Add 8. So if we say we add 8 across the bottom row, that's another way to describe this pattern. So we came up with 3 ways to name the pattern. A toy company packs 40 blocks in every first builder's block. I'm sorry, first builder's box. A teacher buys 3 first builder's boxes for her classroom. How many blocks does the teacher buy in all? Okay, so we have to look at what the problem is telling us, the information that we're given. Okay, there's our important information that I've highlighted. So now you have to decide what to do with that information to get to an answer. 40 blocks in each box, 3 boxes. How many blocks in all? Tell me what you did to solve and the answer that you got. Richie.
I multiplied 4 times 3 and then popped the 0 off the back.
Great.
Got 120.
Okay, so remember when we're multiplying by a multiple of 10, so 10, 20, 30, 40, 50, 60, 70, 80, 90, and even past 100, all we need to do is look for the basic fact. 4 times 3 is 12. And then there's 1 0 here in the factors, so that means we add 1 0 to our product. So instead of 12, it's 120. Who can tell me what unit belongs after, or what label belongs after the product? 120 what? A lot of you are leaving these out on your homework. 120 what? When you can label the number properly, it means you really understand what the problem was asking. Christina?
120 blocks.
120 blocks is the correct way to write it. Nice job. Aunt Sonia has 5 nieces. She gets each girl a $40 gift card to the museum shop. What is the total cost of the 5 gift cards? Let's do a little strategy here. What are 2 answer choices that I can eliminate right off the bat without doing any math? Jojo?
50 and 45.
Why?
Because if you because it wouldn't be reasonable because if you do 40 times 5, it's never going to be the same exact
It
thing.
wouldn't be reasonable. Listen to you, Jojo. It would not be reasonable to say that more than one gift card would be $45 or $50. 45 is only 5 more than 40, and 50 is only 10 more than 40. So it makes no sense. We know we're dealing at least with a 3-digit number here. So now we have 160 and 200 left. What are we going to do to solve this one, Brianna?
You could do 4 times 5 and then equals 20 and then pop on the 0 that's
4 times 5 is 20. Pop on the 0, 200. And we know we are dealing with cost, so it's money, $sign. So we're going to go with choice D for this one. Nice work. A bank makes rolls of 40 nickels. How many nickels would there be in 9 rolls of nickels? 40 rolls of 40 nickels, so that means there are 40 nickels in each roll. 9 rolls. How many nickels? Juliana.
360.
Okay, tell me how you solved.
I did 4 times 9 and equals 56.
Okay, boys and girls, so something that I want to make sure that you're doing. When you are solving these, a lot of you are telling me you did 4 times 9, and yes, that is what you did. But I want to make sure that you're setting it up 40 times 9, not 4 times 9.
40 times 9.
Right. Okay. I'm just making sure you're doing that because you're going to get into trouble if you just start writing 4 times 9. You might forget to pop that 0 on. So we always want to set it up with the multiple of 10. Kyle?
I made an array.
Oh, an array. Excellent. Sita needs 36 hats for a party. There are 6 hats in each package. How many packages of hats does Sita need to buy? So if you look below this word problem, there is already an equation set up with an unknown factor. What is representing the unknown factor in this equation? What are we using to represent the unknown factor in this equation? Richie? Okay, that's the answer. But what's representing the unknown factor? P. So we're using P to represent something that's unknown. So Richie says to get 36 and multiply by 6, P would have to equal 6. And you could either skip count or make an array. So let me demonstrate making an array for this one. So if I have my product is 36 and my one known factor is 6. I'm going to set up 6 rows. And then I'm going to see how many I have to put in each row to make 36. I've made so let's 6. How many do I have now in my array? I have 6 rows of 2. Christian, 12. 13, 14, 15, 16, 17, 18. Should I make another? Okay. 19, 20, 21, 22, 23, 24. Should I keep going? 25, 26, 27, 28, 29, 30. Keep going? When am I going to stop? When I hit 36. 31, 32, 33, 34, 35, 36. Okay, so there's an array that represents 36. It has 6 rows, and now I need to count how many X's I put in each row. 1, 2, 3, 4, 5, 6. Wow, that's so interesting that you realize that, Richie. It's a perfect box. Why is it a perfect box? It's called a perfect square. 36 is called a perfect square number because when I make an array, there's the same number on each side. So it makes a perfect square. We know that a square has all 4 sides equal. Can anyone think of another number that's a perfect square? If Richie says 36 is a perfect square, because when we make an array, it has the same number in rows as it does in columns. What's another number that's a perfect square? Richie, that was so awesome. Good for you. Christina. 8. Okay, Christina says 8 is a perfect square. No. Agree or disagree? Why? Brianna.
I disagree because it doesn't sound like a perfect number to choose.
But why? When you make an array of 8, what does it look like? Brianna?
Like 8 little, like whatever shape you're doing, it looks like 8 little things. And there's no rows, there's only one row.
There's 8. There's 8. Is that a square? Who else can think of a perfect square? 36 is an example of a perfect square. What's another example of a perfect square? Christian? 25 is a perfect square. Why? Right. Perfect square. What's another perfect square? 36 is one. 25 is one. What's another one, Jojo? 42. Not 42. Close. If you're doing the 7, 7, 14, 21, 28, 35, 42, 49, 49. Very good. 49 is another perfect square. Who can name another one? Let's see if we can name them all. This is not on the test, but this is really good math talk, so we can't stop. Juliana. 4 is a perfect square. 2 times 2. What's another one? Okay, we have the 2 times 2. We have the 5 times 5, and we have the 6 times 6. What's another one? Gianna. Is 16 is a perfect square. So we have the 2's, we have the 3, we don't have the 3's. What's the perfect square for 3?
6?
No, not 3 plus 3. 3, that's where you came up with 8 because you did 4 plus 4. You did a double stack. 9 is the perfect square for 3 because it's 3 times 3. All right, we did the one for 2's. We did the one for 3's, for 4's, for 5's, for 6's, for 7's. What's the next one, Brianna? 64. What's the one after 64? 81. Nice work. 100 is also a perfect square because 10 times 10. Awesome. What about 1? 1 times 1. All right. Good job, guys. Mr. Price set up his classroom for Parents' Night. He set up 2 rows with 20 chairs in each row. How many chairs did he set up? 2 rows, 20 chairs in each. How many chairs? Tell me the equation and the answer. Joanna. Nice. Who can tell me how to do this one, 20 times 2, using the distributive property? Christian.
10 times 2 plus 10 times 2.
Awesome. Nice work. All right, a parking lot has 2 sections. Each section has 30 parking spaces. Which diagram shows a way to find the total number of parking spaces in the parking lot? So what kind of diagram am I looking for here? I'm going to use process of elimination on this one too. I'm going to look at one side. I'm going to look at the short side before I look at the long side. So how many squares am I looking for on the short side? If the parking lot has 2 sections and each section has 30 spaces. Jojo. How many squares am I looking for on the short side?
Oh, 3.
Why 3?
Because if you do there's a 3 and a 30, so
Okay, there is a 3 and the 30, but we're looking at 2 sections of 30 spaces. So the short side should have, yes. All right, so Jojo changed his mind. We're going to go with 2 on the short side, right? So I'm going to get rid of B. Exactly. I'm going to get rid of B and D. And now I'm left with A and C because they each have 2. So I need to find the one with 30 boxes. I'm going to go ahead and guess that it's C because it's longer. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, who said yes after I got to 20?
Joe?
How'd you know, Joe? How'd you know I'm right on this one? You're right. Your thinking is good. But how could I stop? Why did I not have to continue? You're doing good math thinking, but you can't tell me why. Tell me why. Abby, tell me why.
When it stops there, you can tell that the other one's shorter.
This one is a 2 by 20 array. This section has to be 10 because this section is 20. Nice work. Bonus, who can find the total number of spaces in the parking lot? The question is only asking us to select the correct diagram. Who can find, oh look, I just made an area model, didn't I? Well, isn't that handy? Let's use this area model that I just made. 2 times 20 and 2 times 10. Find the product of 2 times 20. Tell me what it is. Isabella? 40. And find the product of 2 times 10. 2 times 10, Mia? 20. And now add 40 plus 20, and we get? Great. What multiplication fact do the blocks model? Who can eliminate one choice right off the bat? Eliminate one choice. Brianna. Why? Because we're counting tens. Exactly. Exactly. So we know we're working with multiples of 10 here. We have how many groups of tens? How many groups of tens do we have? How many groups? 2 groups. And then how many in each? 10, 20, 30, 40, 50, 60. Okay, so I looked at it like this, and I said I have 2 groups. So here's what I would have done if I'm being completely honest. I would have said, okay, 2 groups, probably 2 groups of 50. C, let's move on to the next one. What's wrong with what I did? Christina? Right? Right? There's 6 groups of 20. Okay, bonus. What's the product? Christian. Yep. Miss Martin needs 64 buns for the class picnic. There are 8 buns in each pack. How many buns will Miss Martin need? We have a missing factor. We just went over this one before, so this should come pretty quickly. Brianna? 8 times 8 is 64. 8 goes in the missing spot. The coach made a table to show how many basketball teams he will make for his classes. Describe a pattern. Tell me one way to describe the pattern. Mia P. Skip counting along the bottom row by 5s. Whoops. Plus 5, plus 5, plus 5. What am I doing from here to here? Right. And 3 times 5 is 15, and 4 times 5 is 20. Great. Emily plans to buy 54 fruit cups for a breakfast party. There are 6 fruit cups in each package. How many packages of fruit cups does Emily need to buy? What's the missing factor? So our strategies here are either we're skip counting by 6s to get to 54, or we're making an array. Yes? Okay, and what is it? 6 times 9. So P equals 9. All right. Fill in the next 2 spots. This should be quick. Joanna, this one? And the next one? Nice work. All right. These are the big ones. Lauren has 56 stickers to put into her sticker book. Boys and girls, I want to tell you that I looked at the last 2 questions on your math test for tomorrow, and all I did was Rewrite them with different numbers and a little bit of different situations. So if you pay attention now, you're going to get these last problems. Lauren has 56 stickers to put into her sticker book. If she can fit 8 stickers on a page, how many pages will she fill? Write an equation where the letter S stands for the unknown factor, then explain how to find the unknown factor. I'm going to pause. Everybody do this now. So as I'm looking around at the work that you've done, many of us have the same equation. 8 times S equals 56. S stands for?
7.
Right. So in this, S equals 7. If I wrote S times 8 equals 56, is this correct? Of course it is. Tell me what property of multiplication tells us that S times 8 will give us the same answer as 8 times S. Joanna, commutative property, right. Now, second part of the question, explain how to find the unknown factor. Tell me what you did to find it. We've been doing unknown factors this whole review lesson. Brianna.
I tried every number, and then I got to 7, and I found the unknown factors.
So you can work right through the times tables, 8 times 1, 8 times 2, 8 times 3, 8 times 4, until you get to the right one. What's another method?
I skipped count until I got good.
Skip count by eighths till you get to 56. Another great method. What's the other method I told you today? You can make an array. So you're going to set up 8 rows and see how many you would have to put in each row to get to 56. Okay, and also Juliana gave us the suggestion before where she was actually dividing, and she would take 56 and keep subtracting 8 until she got to 0. Last question. The third graders from Kramer Lane are going on a field trip. There are 40 students on each of 2 buses. How many students went on the trip? Explain how you found the product. I did make this one. Okay, I'm looking around. I see some number sentences going down. Good, good. Christina, tell me.
I did 2 times 40 equals 80. Let me write students.
80 students, great. Okay, so all you would have to do for the explain part is say, I multiplied 2 times 40. I added 40 plus 40. I made an array and to show 22 times 40. But you made an array with tens. You drew the sticks, right? Or you could say, I multiplied 2 times 20 plus 2 times 20. You're just saying words what you did. Second part, here's the challenge. Pay attention, because this will be on the test tomorrow. If 40 students from Charles Campaign School join the Kramer Lane students on the trip to the planetarium, what are 3 different ways they could sit in rows of seats with a multiple of 10 students in each row? Yikes. That sounds a little scary, doesn't it? Let's tackle it piece by piece. 40 students from Charles Campaign School joined the Kramer Lane students on the trip. How many students are there all together now? Abby? 120. 80 from Kramer Lane plus 40 from Charles Campaign, and now there are 120 students. That's the first part, done. Second part says, what are 3 different ways they can sit in rows of seats with multiples of 10 students in each row? Let me show you one way. They could sit in 4 rows of 30 students. 4 times 30 is 120 students, and 30 is a multiple of 10. Now you try to come up with 2 more ways, because it asks for 3 different ways, that the students can sit in rows of seats with a multiple of 10 students in each row. So you can't say that there can be 3 rows of 20 and then a couple rows of 5 to make up for the rest. They all have to be multiples of 10. Try to make 2 more ways. As I'm walking around and I'm looking at your math boards, I'm seeing a lot of this. So this would be 3 rows of 40 students. That's good. You have to come up with another way. So think of another pair of factors that one of them is a multiple of 10, that when you multiply them, the product is 120. Here are the other ways. We have 4 rows of 30 or 3 rows of 40. You could have 2 rows of 60 students, 6 rows of 20 students, and then the other combination would be 1 row of 120, and that would be it. Excellent job. That's your study cast.